In this video, we're going to talk about the definitions of a parameter and a statistic. And actually, understanding the difference between a parameter and a statistic is just as important in statistics as understanding the difference between a sample and a population. Okay, so let's go ahead and pull up the definitions here. So a parameter is a numerical observation describing some characteristic of a population. Okay, so population is the key word now. All right, so parameter and population. Then a statistic is a numerical observation describing some characteristic of a sample. All right, so population for parameter, sample for statistic. So let's think of some examples. We know some statistics already, like the sample mean, the sample median, the sample. Maybe you even heard of standard deviation or variance, the sample range. All of these are numerical observations. Okay, and if they come from a sample, as in most of the times they do, you observe from a sample usually, and then you try to make conclusions about the population, or you try to make conclusions about a parameter. Okay, so the population mean would be a numerical observation from the population. So population mean, population standard deviation, population variance. Those would all be numerical observations describing the population. All right, so let's go ahead. We'll go ahead and now do an example. So say we have a researcher that is interested in knowing the average age of all American college students, right? They're interested in knowing the average age of American college students. However, you don't have the researcher doesn't have the resources or time and energy to sample every single American college student, which, by the way, if they went out and got every American college student, that would be conducting a census, right? When you collect every member of the population, that is a census. But most of the time you don't have those resources. So instead, the researcher observes a random sample of 5,000 American college students, finds that their average age was 24 years old. So now let's determine, what is the population? Let's think through these questions here. What is the population? Okay, so we know from the previous discussion, previous video, that population is the set of all observations of interest. Right? So in this case, what are we interested in observing? We're interested in observing the age of all American students. So that's going to be the population. So let's write that out. The age, right? The age of all American college students. All right, so now let's think this through. Now, what is the sample? So what is the sample? Well, the researcher observed a random sample of 5,000 American college students. Okay, so remember, sample must be a subset of the population, and the population is the age of all American college students. So then the sample then would be the age, right? So what you observe is the age of the 5,000 sampled students. Okay, all right, that's the sample, the age of the 5,000 sampled students. Okay, so now what is the parameter of interest? Okay, so we know parameter. This parameter is going to be some numerical summary sort of measurement from the population, right? So what's the parameter of interest? Well, we're interested in knowing the average age of all American college students. So that's going to be the parameter of interest. The average age of all, right, of all American college students. So the average age of everyone in the population, right? The average age of everyone in the population, or the average of the population. Okay, so now what's the statistic? So the statistic comes from the sample. So in this case, this would be the average age of the 5,000 sampled American college students. Okay, so the average age of the 5,000 sampled college students, which we actually were given what that equals. So the statistic in this example was 24 years old.